Hello guys and welcome to Avoiding Coding Catastrophes. My name is Ryan Wolf and I'm going to be taking you through an interesting topic today. We're going to be talking about loops and decoupling the code within loops. Alright, so I'm going to be doing a series of about 3 or 4 lessons on loops, and this is going to be the first one. I think this particular topic of decoupling code within loops is one that's kind of not taught well in our industry, and kind of I just wanted to give it a good shot here. So thank you for joining me. Firstly, I'm going to give you a story from early in my career, and hopefully it resounds with you, and you will see exactly why it is you need to decouple your code and what exactly decoupling of code is, right? And I'm going to show you some methods of doing that just a little bit later in this video. Alright, so what is the story from earlier in my career? Okay, I was given a task to create a program that, based on a customer's transaction and the status that transaction is in, this company wanted to send text messages automatically to these particular clients. So for instance, I would have a list of text message templates, and within there I would have rules to say when a customer is in a pending state, for instance, and it's been in a pending state for 2 days, send them a text message. Thereafter, I want you to send them 4 sets of or 4 repetitions of that same text message every 3 days. So, something like that, okay? So we've got a bunch of business rules around this. Now, what's important to understand about this is that I'm going to need to do some loops in this whole thing, right? You can see that there's a bit of complex logic, and I'm going to need to do loops, and probably loops within loops, right? So I go about and I do my job. I create the loops, I create the sending of the text messages, I log it in the database that it's been sent, I have it all covered, right? I do my test cases on the local and on staging, and I release it to live. Okay, so here I come the next day, and I want to check, okay, I had a cron job that was supposed to go off and trigger this and send out all of these text messages to appropriate clients. I go to check a client that should have been sent a text message because he's got a transaction and according to the rules, and funny enough, there's no trace of that client getting a text message. So I wonder, did it even run? What happened? I go to the logs and I see, sure enough, this job was run. This particular client did get a text message sent to them. Why hasn't it been written to the DB? I confirm with the text message provider, this text message has definitely been sent, but still nothing in the database. I go back to the code, and long story short, because trust me, I didn't just get this in 2 seconds, but I go to the top of the service and I see an annotation at transactional. Now we don't, in all of our services, we do not have at transactional. In this particular framework that we use, by default, when you create a service, it adds that at transactional. But we always just take it out because it's for us, we don't want to use transactional in that way. We don't want to use it on just an entire service scope, and for exactly this reason. Now, what is transactional, you might be asking? Okay, so transactional is when you want to do a few things. Maybe you want to insert into a database, you want to insert another record in the database, and maybe you want to update something. So let's just say you do a credit transaction, a debit transaction, and you update a global balance, right? And you want all of these to run together, but if any one of these three go wrong, you want to undo or roll back everything else. So you don't want it to update the balance, to fail to update the balance, but the credit and debit have gone through. You don't want to have the credit gone through, but the debit doesn't go through. There's something wrong. So you want all of these three to go through together. Okay, so they're a package. If something goes wrong with any of them, all of them get rolled back. All of them get undone. Now, because I don't know I'm in a transactional scope when I'm writing this code, and in general, I shouldn't be in a transactional scope, I just assume, okay, it's using the default method, which basically it auto commits as it's going after every single write to the DB. So I'm like, I'm happy with that. I'm good. This is going to work for me. So guess why these records weren't written in? So as I'm going through this loop, we're still in the same transactional scope. And so say one customer would have a text message sent to them, it would write it to DB, but not committed. Then it would go to the next customer, it would send the text message, write to DB, but not committed, and these two would be in the same transaction. And if there was 100, well, there would be 100 writes waiting to be committed in this transaction. Now, it just so happens, very close to the end of the processing of all of these text messages, someone's got a wrong phone number, and it goes to our SMS provider. SMS provider comes back with an error. In our code, we throw an exception. It goes into my try catch. It just carries on as it should. But the part I didn't know is that as soon as it throws that exception, it rolls back every single one of these transactions, every one of these writes to the DB. So basically that was my issue. I had to take out the transactional, I had to test all of the code in the servers and make sure that it still worked as it should, and just further check my own code there, and it worked wonderfully after that. Okay. So I think there's a bunch that I could learn from that, and that I got wrong in that particular scenario. And I did learn a lot of lessons, and one of them I'm going to help teach you today. Okay, so here is my application. Okay, let's not pay attention. This is just the client applications. This is the authentication. But what's really important is this part here. Okay, so I've on purpose made these rather big to illustrate that this is what they call a monolithic architecture. What does a monolithic architecture mean? It means all of your code, all of your business logic for this entire system is sitting in these services. Okay, there might be separate services. There might be a text message service and a transaction service, but it's all within this application. all of the endpoints for this application are sitting in here. All the data for this application are sitting in the same DB. Okay, which there are advantages, but there's definite disadvantages to having a monolithic architecture. And one of them is that your code is certainly not decoupled at all in this particular architecture. And I prefer what they call a microservices architecture in many cases. There is cases for a monolithic architecture, but I would say 90% of the time a microservices architecture would do you better. Okay, so what is that? A microservices architecture means we'd create another app. Okay, another basically back-end application, and this would also have authentication and whatever, but just forgive me, I'm not going to include that. I'm not going to include the controller side. I just want to show you a very basic idea of a microservice, and this is a text message service, and everything relating to text messages would be within this particular microservice. Okay, so my text message templates would be sitting in this database. My records of what text messages have been sent to who would be sitting in this database. I would get the data as needed from the service, and basically I would outsource everything about text messages to here. Okay, so I've still got my loops and everything in this business logic here, but now when I'm sending a text message, I would say, okay, I go through my loop, I say this customer needs to get this specific text message template, and then I would delegate it to this text message service. This would happen completely out of the scope of any of the logic here or any of the function there, and it would happen in a single request. So all you would be doing is saying, send this customer that text message and log it to DB, and this would send that text message and log it to DB. Now that takes away it as you can see, it decouples the logic and the function from each other, because you can see, you would think, okay, well, even though I'd built in my try catches and things like that, you found that one failure can affect other parts of the program in an unintended way. This simplifies things a lot, and simplification is definitely a plus. Okay, so this is our first method of decoupling of code, and this is the microservices architecture. I'd encourage you to read up on that a little bit more. Okay, so that's not the only way. There's always more than one way to skin a cat, and in programming there's many different ways of doing things, and quite often, there's best practices and all of those, and we need to follow that. But there's also times when you need to make decisions, and it's not a matter of this is better than that, or message queue is better than microservices, or microservices is better than message queue. It's that there's advantages to microservices architecture, and there's advantages to message queues. It's not one or the other. So, for instance, an advantage to a microservices architecture would be that you can really scale it up quite heavily, which is great. It also means that logic is very much split up. You would have and in a smaller chunks, so the likelihood of you creating really good code is actually quite a lot higher in a microservices architecture. Code is decoupled, as I've said before. Now another way, and maybe just so you understand a bit better, let me give you a disadvantage of microservices architecture, and that would be that it would take longer to implement than like a message queue type of solution, which I'm going to show you now. There's overheads. You would need a separate database. You would need a separate deployment. You would need, so there's overheads to having a microservice. Okay, message queue, a lot simpler, but it also doesn't fix some of the problems. It fixes most of the problems, and it does decouple code quite effectively. But some of the scalability issues, you're still going to have them, and but it's not a bad solution. Very quick to implement. I quite like message queues. So this is our text message queue. And what we're going to do is we're going to add a consumer here. Okay, so what's going to happen here is our business logic service is going to go through the loop it was already going through, right? It's going to decide, okay, this customer needs to get this text message. It's going to put it into the queue, and the queue is just going to drip it one at a time, one customer at a time into the consumer. Now this consumer, every message is processed in a totally separate thread from any business logic that was happening before that. In fact, we might even come back here to a method just to send our text message out from the consumer, but it's in a totally different scope from our loops and all of that. And in this way we can decouple the code. Okay, so long story short, I would love for us to decouple our code as best as we can. Separation of concerns. Another way of putting it is separating code into separate units of execution. This is powerful because it makes things simpler. Okay, it makes it easier to test. It makes it it separates your logic from your function, which makes a lot of sense to me. Okay, so that is my advice. Try to decouple your code as much as you can, especially when you're in complex loops and things like that. Try to do that. Okay, now a second thing that I could teach you quickly, and this is just like a tip at the end. Really remember that decoupling part. But I've also got a good tip for you. Now, having started with I would say one of the biggest problems in that whole issue with the text message service was not picking up the transactional annotation at the top of that text message service, right? And one of the reasons I've picked up over the years, and that I never picked it up, was because of attitude. And there's a powerful attitude that I can teach you. And when programming, you want to have a bit of a suspicious mind. Yeah, that sounds bad. It sounds like a bit paranoid, but but you've kind of got to. For instance, when you start a piece of code and you go like, okay, I'm in this service. I bet you there's something wrong with the service. Let me go to the top of the service and see if there's any. What is it implementing? What is it? Are there any annotations at the top here that could catch me later? Okay, there's nothing wrong there. So let me go and do my method. But I think my method is wrong. Let me check. Okay, everything is fine with the way I've done the method. And then I go and write my code. Then when I'm looking over it, I need to be a little bit suspicious again. Because I promise you, if you go through your code afterwards and you go like, yeah, I'm sure it's all fine, there's no problem, and just, let me look over it, but I mean, hey, I've spent a lot of time doing this, it must be right, let's just look, looks fine. I promise you, you're not going to pick up the issue. It's better to go through. I think line number 1 is wrong. No, line number 1 is fine, there's nothing wrong with it. Line number 2, this guy, I'm sure there's something wrong with this. And go through it with a suspicious mind. Look for things like, is there any environment specific stuff here? Is there anything that I've missed out? Anything that's not going to work on when I take it to live? Anything that I've not considered? And so having that little bit of a suspicious mind is that even the right way of putting it? A suspicious mind. Yeah, okay. Maybe you can look at it as have a questioning mind. Question every step of the process and say, okay, I am suspicious and I suspect that this is wrong, and question that part and then move on. Okay, so thank you for listening to me. I hope you enjoyed this video. Thank you for your time. And I'll have another video out as soon as I can. I'm kind of excited about this. Thank you for being on this journey with me. Big love. Cheers.